So in this case, what you have to consider, because it will not be in a single plane now. So balancing of several masses rotating in different planes means you have to consider the different planes. So if 4 planes are there, 4 different planes, 4 masses will be attached in different planes. So in this, apart from taking a force polygon, you have to take couple polygon also, because the distances between the planes also you need to consider. So there you will be getting the couple. So let us see. So when several masses revolve in different planes, then they may have to be transferred in reference plane. So you have to consider one reference plane and you have to start from the problem from there. So from their reference plane, whichever masses are connected with that plane, you have to consider the length from there. Okay. So the effect of transferring a revolving mass that is in one plane to a reference plane to be considered, and from there you want to measure the values from that reference plane. Okay. So to make a balancing of this entire several masses at different planes, so you have to consider these two conditions. One is the forces of the reference plane, that is to be equal to 0, and one is the next one is the couple. Okay. So this you need to consider. One is about the forces and then one about the couple. So this summation should be equal to 0. So a force polygon and couple polygon should be completely a type of closed polygon only in this condition. Okay. So let us see how to consider this. Here you can see there are 4 masses in 4 different planes, right? So here 1, then 2, 3 and 4. So 4 are different planes, and then you can see the position of planes here in this format, and then angular position you can see in this figure. Okay. So you need both type of figure so that you can understand it correctly. And here the reference plane is considered at this position as plane L. Okay. And the distance measured from this plane, the reference plane. So here from the reference plane, the length of plane that is from reference plane to the first one is L1. Then similarly the distance of second mass from the reference plane will consider as L2. Then same way the mass M3 we consider as they are L3, and the fourth mass the distance L4. Okay. And here only one mass you are not going to use for the balancing it. So for 4 planes we are using 2 different masses at 2 different planes to balance it. Okay. So apart from 4 masses, you need again 2 extra masses at 2 different planes, that is being considered. So we have taken the planes L and then M respectively, and from the we have taken L as the reference plane, and if you take L here, so for mass M also you have to take one reference plane. Let us take it as LM. Okay. So the same thing is being shown in this angular position. So starts from here. First one, that is mass M1 at a distance of R1, then M2 at a distance R2, then M3 radius R3, and similarly also the angle can be measured. So this angle is theta 1, then this angle they are given as different angles, theta 2, theta 3. Okay, like that you can consider. Okay, same way how you had got for the same single plane, they are also different plane. So you will understand the position of planes only in the first figure, that it is in different plane. If you see this angular position, it will be seeing it is a type of a single plane only, but here it is in different plane. Then mass 4, M4 is also given there. So the balancing masses we consider here, that ML will be at these positions So this position you have to find out. This is not given directly. It means you have to find out this balancing masses. Okay. So in this case, how you do it? So first I'll tell some steps how to do it. So the magnitude of this balancing masses ML and M. So they are in planes L and M respectively. And take one of the planes, say we'll take as L as the reference plane. So always you have to take one reference plane and you have to measure the length from that reference plane only. So whatever value is there with respect to, if the distance between 3 and 4 is given, okay, and 2 and 3 is given, but always you have to take the distance from the reference plane only. That's why it is reference plane. And even the reference plane will have minus direction and positive direction, because if you take reference plane at the extreme end, then other side will be all positive. But here if the reference plane is taken in between, left side we have to consider as one as negative and right side we have to consider as positive. Okay. So distance whatever is measured on the left side, that is considered to be negative, and then on the right side we take consider as positive. Okay. And you have to draw, and first you have to get all these four masses and then draw the table for this. Okay. So I'll tell you how to draw the table. So first, whatever planes are given, that you need to note down. So what is from this one, 1, then L, then 2, 3, M and 4. Okay. So same thing we'll arrange it here. 1, L is nothing but a reference plane shown by RP, then 2, 3, then M and 4. Then similarly the masses will be M1, ML, M2, M3, MM and then M4. Okay, so these are the masses. Then correspondingly radii. So radius for M1 is R1, M2 is R2, MM is RM, then M3 is R3, like that. So we take here R1, RL, R2, R3, RM, R4. Okay. Then centrifugal force divide by omega square, because we always neglect omega, because omega is common for all the things. So we don't consider the omega part, only we go with M into R. Okay. So centrifugal force divided by omega square, that is M into R. So product of 2 and 3. Okay. So product of 2 and 3 you have to do it. That will be M1 R1, ML RL, M2 R2, M3 R3, MM RM, then M4 R4. Then now distance, this is the new thing. Previously you have done only with M into R. Now extra L also will be considered to get the couple value. Okay. So this fourth one values you have to use for the force polygon. Okay, this you have to use for getting the force polygon, whereas the couple, whatever value you are getting, that will be used for the couple polygon. Okay. So let us see how these planes are considered. So this is reference plane, means it will be 0. So the left side, the length is given as L1 here. Okay. And then it will be negative value minus, so it is minus L1. Then this is reference plane, so this will be 0. Okay. Then the distance from reference plane to the third one is L3. So L3. Okay. Then here 2 was L2, then this one mass M, LM, then 4, L4. Okay. So LM and then L4. So all the length is being taken. Now the sixth column here, it will be a couple divided by omega square. So it will be nothing but M into R into L. So product of fourth and fifth. Okay. So product of these two, M1 into R1 into L1, that is minus. So it becomes M minus M1 R1 L1. Then this is 0. So 0 into ML into RL, it is 0. Okay. Then M2 into R2 into L2. Same way M3 into R3 into L3. Then MM into RM into LM. Then M4 into R4 into L4. Okay. So these are all things you got. Now correspondingly with the values what I will be getting, you have to draw the force polygon using these values to get one closed loop, and these values you can use to draw the couple polygon. So you can see they will be getting force polygon, couple polygon like this. Okay. So when you solve the problem with the exact values, that time you will understand correctly how, which values, which type of things you need to consider. So this is just the procedure how to solve the problems. So that is being shown. So when you use the correct values, then you will understand how these problems can be done. Okay. So next step, the third step will be, here you can see why we take actually the reference plane, because when one of the couple value you will be getting 0, means that will be neglected automatically. When it is 0 means you don't have to draw. So whichever unknown values are there, if you take one as 0, automatically that gets cancelled, and to find out other unknown becomes easy. That's why we take actually reference plane, so that that one part becomes 0, and to solve the problems becomes very easy. Okay. So that is actually the use of taking the reference plane, and that to get it 0 and to get the couple as 0 there. Okay. Next, the third point now, a couple may be represented by a vector drawn perpendicular to the plane of the couple. So the same thing, whatever values you get here with respect to the what is shown here in this position, so that is M1, M2 and M3 and M4, same thing you can represent in the form of vector by taking the perpendicular to that couple. Okay. So here if you take these conditions, you will be getting the figure like this. Okay. This will understand exactly when you do the problem. The same way, next you have to take the couple around the counterclockwise direction to get the convenient that is shown in the figure D here. So the couple vectors are drawn radially outwards for the masses on one side of the reference plane, and radially inward for the masses on the other side of the reference plane. So then next we can get the couple polygon to get the unknown values. So if any unknown values is there, for example to get mass of M position, so you can get the last whichever unknown value is there, O dash D dash, if you take this part, and that from there you can get the unknown mass which is to be measured. Then same way, which is again unknown M, that is ML, that also can be calculated by the force polygon. So which is left out, that is EO. So this length, so whatever is there, that will be nothing but to get the mass of L. Then finally you get the angles also. Accordingly, if you trace back to the space diagram, you will be getting the exact angle also. Okay. So this is the procedure to draw the in different planes. So let us solve the problem now. So the same procedure will apply. We will go slowly, one by one you can solve along with me, so that you can get it more comfortable. Okay. So just do along with me. So I will read the question. So in the question it is given that a shaft carries 4 masses, that is A, B, C and D. So A is given as 200 kg, then B is given as 300, C 400 kg and D 200 kg. So same thing, we got the given data here. Then at respective radii also given. So radius, it will be nothing but for A, B, then C and D. So automatically you get the radius 80, 70, 60 and 80. Okay, mm. So millimeter we convert to all into meters. So get 0.08 meter, 0.07 meter, 0.06 meter and 0.08 meter. And the length is also given. So the plane's length, that is from A, measured from A, it is 300 mm, 400 mm and then 700 mm. Okay, so the length, position of this length is also given, and the angle which is measured in the anti-clockwise direction, from A to B it is 45 degree, from B to C it is 70 degree, and from C to D it is 120 degree. Okay, and the balancing masses are to be placed in planes X and Y. Okay, so this apart from planes A, B, C, D, you need to get the plane X and plane Y. Okay. Then the distance between the planes A and X is 100 mm. Planes that is between the X and Y, it is 400 mm, and between Y and D is 200 mm. If the balancing masses revolve at a radius of 100 mm, find their magnitudes and angular position. Means you have to find out the balancing masses, that is mass at position X plane and mass at position Y plane. So same thing we have considered. Let us take mx as the balancing mass to be placed in X plane X. Then my we take balancing mass to be placed in plane Y. Okay. So according to the given data now, the first step is to get the position of the planes. Then we get the angular position. Okay. So figure A and B, that is first thing you have to draw this figure. In the question, only this question will be given. Using these values, you have to first draw the figure correctly. If you draw figure correctly, then only the next step will be correct. Okay. So always when the problem is given, read the problem correctly and get the data. Okay. If you do small mistake taking one length here and there, your entire 20 marks will go. Okay. So the first step is very important, because step marks will be there, but only thing if you do first step correctly. If you do first step wrong, means entire 20 marks will be losing directly with getting 0. Okay. So now using this data, first draw this figure. Okay. I'll go slowly, just note down the things what I am telling. So these are the initial position A, B, C, D, which is given in the question, and these are the angular position. So first I will take the position of planes as given in the question. So what is given? The mass and radius, this is okay. Next, he has given the measurement from A, 300, 400 and 700. What is these positions? It is the positions for B, C, D only, because A, B, C, D is given, and if it is measured from A, that is from this, they are given, and at 300, 400 and 700. Okay. So from A, the value of the masses B, C and D, masses B, C and D is 300, 400 and 700. Okay. So from A, B is 300, from A the C is 400, and the D from A it is 700. Okay. So this is first given in the first line. Next, after that, the angle is given, that is the for the angular positions. Okay. So this will be the initial 0 degree, that is the first mass. So from there you have to measure A to B is 45 degree. A to B is 45, means after A from B, this will be 45, angle of 45 degrees. Next, B to C is 70 degree. So from B to C, the angle is 70 degree. This angle is given. Okay. Then C to D, it is 120 degree. Okay. So C to D, this is 120 degree. Okay. So these angles are given in the question. The next one, the balancing masses are to be placed in X and Y. So after giving this A, B, C, D, you have to take for the balancing masses to be placed in X and Y. So you have to get the extra X and Y, and the distance between these planes is given, that A and X is 100 mm. So you know the position of A. So A and X is 100 mm. So this is given next. Next, what he has given, the between X and Y is 400 mm. So the distance between X, after taking X and Y is, he has given as 400 mm. Okay. So you have to take the distance of X and Y as 400. Okay. Next he has given that between y and d is 200. So y and d is 200. Okay, so total you get same thing, 100 plus 400 plus 200. So it is total 700. So it is matching here. Okay, so all positions he has given correctly in the question. So first you have to read the question and get all this length. Okay, this is the first step to get the figure of this figure A and then figure B. Then if you do this correctly, your half of the work will be over. Okay. Next you have to find out the unknown things at radius of 100. So means he has given the radius of Rx and Ry as 100. So initial Rx and Ry also is given. So from this radius you have to find out the masses of X and Y. Okay. Now you have to assume one reference plane. Okay. You can take anything as a reference plane, not that any fixed things are there. From this 1, 2, 3, 4, 5, 6, anywhere you can take the reference plane. But how you take the reference plane, that is also important. Now suppose if you take A as a reference plane, what will happen? If you take A as a reference plane, what will happen? Then you don't know the value of X, you don't know the value of Y. Then two unknowns are there. How will you find out one unknown value? Very difficult. Okay. So why you take a reference plane on the things which is not given, that if you don't know X and Y, so any thing which is unknown, that is X and Y, in that X or Y, if you take a reference plane either X or Y, then only you will be finding that one will be a reference plane value will be 0 because it will be reference plane. So multiplication in the couple polygon will get 0. So automatically the unknown value from there can be measured. If you take X as reference plane, means the couple value of this reference plane will be 0 because we take here length as 0 because this is the initial position. So automatically you get the value of Y. And if you take a reference plane as Y, automatically you can get the X. Okay. So always you take whichever plane unknown thing is given. So you have to assume that plane as the reference plane. So here in this case, we assume the plane X as the reference plane. So here we take this one as the reference plane. So towards left side we take it as minus, and towards the right side we take it as positive. Okay. So now you have to first draw the table. So same type of thing. So for planes, first column will be always the plane, that is A. How it is shown in the figure, same way you have to draw it. Okay. A, X, B, Y, B, C, Y, D. So A, X, B, C, Y, D, and X is the reference plane. Next, mass value already given, right? A, B, C, D masses are given. So A is 200 kg, B is 300, C is 400, D is 200, and these two are unknown masses, means you have to find out the value of mx and my. So we keep it as it is mx and my. Next, the radius. So radius is given in the question, values were given 0.08, 0.07, 0.06, 0.08, and even Rx and Ry given in the question, that is 0.1 meter. So we take Rx and Ry as 0.1. So the radius is known for all. Next, centrifugal force divided by omega square, means only we take m into r. So only the product of 2 and 3. The next column 4 will be the product of 2 and 3, that is m into r. Okay. So 200 into 0.08, 200 into 0.08, you get 16. Mx into 0.1, you get 0.1 into mx. Okay. 300 into 0.07, you get the value of 21. 400 into 0.06, you get 24. Then my into 0.1, you get 0.1 into my. 200 into 0.08, you get 16. Okay, so these are all the values you can use to draw the force polygon. Okay, next, distance from the plane, that is length, what is you are drawn here, position of planes. So this you have to consider in again in meters. This all thing were given in millimeter. Okay, so considering this as a reference plane now, what will be the reference plane from here to the value of A? It is 100 and it is minus. Okay, so minus 100 means minus 0.1 in meters will take. Then the reference plane on this x, automatically this is 0. This is the initial reference plane. So you get here 0. Next, from reference plane to B, what is the value? It is 300 minus 100, right? 300 minus 100, it is from here to here, what is the value? It is 200. Okay, so same thing we take here, 0.2 meter. Then C, so C is how much? This is 400 minus 100, it is 300, means 0.3 meters. Next, Y is given as 500 minus 100, 400, so 0.4 meters. Then the last one, 700 minus this 100, this is from X to D, it is 600, so you get 0.6. So these all values are the values for L. Okay, so this was M, then R, then this is M into R. Now this product you have to take, M into R, now into L. So we will be getting here MRL, M into R into L. Okay, so product of 4 and 5, product of column 4 and 5, you will be getting the last column, that is 6. So 16 into 0.1 minus the rate minus 1.6. 0.1 mx into 0, you get 0. 21 into 0.2, 21 into 0.2, you get 4.2. 24 into 0.3, you get 7.2. 0.1 into my, you get 0.4. That is 0.4 multiply, you get 0.04 into my. Then 16 into 0.6, you get 9.6. Okay, so like this you have to first draw the table. Now using these values, you have to draw force polygon and couple polygon. Now by looking at these values, which you will do first, means which we will start with force polygon or couple polygon? Anyone?
Sir, couple polygon only, sir.
Why? Because you have to understand, because in force polygon if you draw, there are two unknown, mx and my. So you have to take two things, and two unknown means you will not be able to complete the polygon. Okay, whereas if you take couple polygon, what will happen? Only one is unknown, because one becomes 0 there, and only my you can find out. Okay, so first you have to draw couple polygon and then come back to force polygon. So you will think, why if not force, why first couple? So whichever is having less unknown, that you have to solve it first, so that you get the value of my. Now once you get the value of my, you can substitute in the column number 4, then you get the value of my also. Once you get my, then you can substitute my value and then you can calculate mx, right? So that becomes simple. Okay, so now we'll discuss how to draw the couple polygon. Okay, So the balancing masses mx and my and their angular position will be determined graphically. So you have to use graphical method only for this. So first step, you have to draw the couple polygon with these values. Okay, so column number 6. Take a suitable scale to take this 1.6, 4.72, 7.2, 9.6 and all. Okay, so take a suitable scale according to that. You know the values are in this range, around 1 to 0 to around 10. Okay, so to take a convenient scale, how much you can take. Okay, I'll not I'll tell you exact how much sheet you have, that much you can take. Okay, so taking this, now you have to take one by one the values of this couple polygon. Which direction? The direction which is already given in this. Okay, so you know the positions, A position, B position, C position, D position, the angles are given. Okay, so draw these angular positions, and on the same sheet, just after drawing this, below only if you draw, it will be easy for you to draw the parallel lines from here or perpendicular lines from here, so it becomes very easy. Okay, so always what you do, when you drew in the sheets, you exactly take this all in the one side of the sheet only. In exam, you will be getting one big sheet, that is A1 sheet, and there you can solve comfortably with taking good amount of scale. Okay, so along with your answer booklet, you will be getting the sheet also. No compulsion that you have to do in the sheet only, but if you do in the sheets, you will be getting accurate answers. You may get good marks for that. Okay, because if you do in the notebook, there are chances that your paper may tear off, or if you may take a lot of scale problems and all. Okay, so the sheet, if one sheet is given, in that actually in one sheet only you can cover all chapter problems, because it is big sheet. You can take a suitable scale in that sheet, and you can solve all problems, balancing or cams or static force analysis, or even the first second chapter, whatever you have done, velocity analysis, acceleration analysis, everything in the same one sheet only, all problems will fit. Okay, so you can take a good scale there and you can draw it. So now so how to take this 1.60, 4.2, 7.2, 9.6 and all, let us see. So the first step for the drawing this couple polygon, so we'll start with the initial position of 1.6. So 1.6 is what? It is minus, means you have to take reverse. So here you can see the mass of the first one, that is for the first plane, it is 0 degree, means now you have to take opposite direction in the form of 0 degree. So I take a reverse now. So let us take the values as O dash to A dash. So this I will move by 1.6 units. So you can take a suitable scale for this. So get O1 dash to A dash. Next, after O1 dash to A dash, the next value is 0. So no need to worry. Next is 4.2 for B. So the position is known to you from the angular position. So that angle, whatever is there, 45 degree is there. So from dash A dash to B dash, the unit value is 4.2. So this take an angle of 45 degree, or just parallel from the plane there given as for B. So you take units of 4.2. So this 4.2 will be positive. So we take the same direction. Here it was negative, so we have taken opposite direction. Now from B dash to C dash, next value is how much? 7.2, positive. So same direction as of C. Here you know the position here, C direction. Angle is 45 plus 70 from horizontal plane. So that angle you will take from B dash to C dash to get the value here of 7.2. So 7.2, you draw a line up to C dash. Now next one 7.2, after that D1, D 9.6, and this is not known to you. So the remaining will be the value for 0.04 my. So you take 9.6 now. So 9.6, the angle is known to you. This was this one angle, so that is 45 plus 70 plus 120 from the horizontal plane. So this will be getting 9.6 here up to D dash. Okay. Now once you get this D dash, so whatever is the remaining one, that is O dash to D dash, remaining value, so that will be nothing but the balanced couple value, that is 0.04 into my, the remaining one 0.04 into my. So this will be equal to this length, that is O dash to D dash, right? So this will be solving. So D dash to O dash will be the balanced couple, and that will be equal to 0.04 my, that is equal to D dash O dash. So we get the value of D dash O dash as 7.3. So if you take exact scale, whatever you have taken 7.2, 9.6 like that, so this value in that unit if you take, that will be value of 7.3 something, and this if you equate 7.3 to this 0.04 into my, you get the my value as 182.5 kg. So this will be the answer for my. Similarly, if you get the angular position, so you know the here the angle also, because you have drawn the line balance couple. Okay, so take this same thing my, whatever you have drawn here, this one, and draw now this line parallel to this vector D dash O dash in the figure B. In figure, go to figure B and take this line parallel and draw this parallel to this vector D dash to O dash. You get the position for y. You get the position for y. So same thing, whatever you have drawn here, no, same thing. This you take parallel and draw it over here. This one. So if you take this one, this will be the value of theta y. So you get here my, whatever is there. So theta y angle. So by measurement of this angle, you get theta y as 12 degree. You get theta y as 12 degree. Okay. Now once you get the value of theta y and my, you can substitute this my now in this table for figure this column 4, and you can get the value of now this, so 0.1 into my. Now in this force polygon only one unknown will be there, and similarly you can draw the force polygon now. So after couple polygon, next now the last step will be to get the force polygon. So using that column again I will be using the values there, whatever you got 16. Okay, first is 16. So next 0 to 08 we will take the 16 value. Then A to B 21. Then B to C 24. Then C to D it is 16. And then D to E it is 0.1 into my. So already my is known to you now. So that 0.1 my if you do that, you can take here, and the remaining one, so that will be nothing but the balance force. So this remaining part will be 0.1 into mx. So you get this value by measurement as 35 or 36 something, so 35.5, and this one will be nothing but equal to 0.1 mx will be equal to vector EO, so that is 35.5, and from there you get mx as 355 kg. Now take this vector, whatever you got vector, and place in the figure B. So we are getting this now. So this will be nothing but at this angle, you measure the angle. So you get the angle of the x as 145 degree. Theta x will be 145 degree, and the mass is 355 kg. Okay. So this two unknown masses you have found out. The balanced masses can be found out. Okay. So like this you need to solve.